So here we go. Yes, we're on the back side of page 50, looking at 6.2, and we are going to find what's called the dot product of V and U. So when I read this, kids, I say V dot U. I never say multiplication because this means something different. This is called the cross product. We are not doing that today. We are doing what's called the dot product. You see why it's called the dot product? Yeah. And when I read this, I say V dot U. All right, so I'm going to find V dot U. For my first two vectors, this is so easy. Here are my first two vectors. I'm going to find the dot product of these two vectors, and here's how I'm going to do it. V dot U is 1 times 2, negative 2 times 3, added together. Now, what did I do? What's this? What are these numbers? Where did they come from? Those are the x's. So I multiply my x's. Now, where did these two come from? Those are the y's. I multiply my y's. So I'm going to add them together, and the answer to the dot product is a number. You get a number, and the answer is negative 4. Yes, we've got some people absent today. How are we going to explain to these people who are absent how we find the dot product? What do we do to find the dot product? X times x, y times y, add them together.
You always add them together.
Always add them together. The rule is x times x, y times y, add them together. Now that's easy. I'm going to say it one more time, and then we're just going to do it. We're not going to talk about it anymore. If you want to find the dot product, you do x times x, y times y, add them together. So you should have no problem with the next one. 1, negative 6, and 3, 1. What's the dot product of those two vectors? We're going to multiply our x's, we're going to multiply our y's, and we're going to add them together, and our answer is negative 3. Hey, let's get the fog out of our brains. This is easy. Oh, I wrote it wrong. I'm sorry. How's that? Is that better? Yeah. I'm sorry, I wrote it wrong. All right, do C. I'll stop and you do it on your own. You'll probably get it right anyway. What's C? What's the dot product for problem C? Negative 2? Everybody get negative 2 for the dot product for C? Yeah. All right, do D. What's the dot product for D? Zach?
I got 24.
You got it right. 24, right? Everybody get 24? Okay, nod. You got 24? Okay. All right, let's look at problem number 2. Now we're going to use the dot product. You're thinking to yourself, okay, this is really awesome, Mrs. Ford. I love doing the dot product on Friday. What's it for? Well, one of the uses of the dot product is to help you find the measure of the angle between two vectors. All right, so you're going to need to keep track of these steps. It's a very easy process, but there are some steps involved. Step 1, find the dot product. Okay, all right, you know how to do that. So what did you get for your dot product for these two vectors? Negative 1. All right, so that's step 1. Find the dot product. Now, here is the new rule. The dot product, which you already know is negative 1. You already figured that out. Equals the magnitude. Now, let me write this where I have more room. The dot product equals the magnitude of the first vector times the magnitude of the second vector. And what do I mean about magnitude? When I use the word magnitude, what am I talking about? The length of it. Times the cosine of the angle between them. So you have two vectors here. Here's the angle between them, right? That's the one we're looking for. So the rule says for the angle between two vectors, this is the rule for the angle between two vectors. The rule says your dot product, that number, which you already told me was -1, will equal the magnitude of your first vector. Okay, here's your first vector. It looks like this, right? Isn't that what that looks like? What is its magnitude? How long is that? Do your Pythagorean theorem. What is its magnitude? Root 10 times, all right, now I need the magnitude of the second one. All right, so my second vector looks like this, over 1 up 2. What's its magnitude? Pythagorean theorem, root 5. Times the cosine of the angle between them, which I'll just call theta. So now I have this equation. That's my rule. One more time. For the angle between two vectors, the rule says dot product equals magnitude times cosine. Now how can I solve that equation? Well, first of all, let's multiply these together. What is root 10 times root 5? Root 50. Now, I know that simplifies. I'm not going to simplify it. It is not the answer to the question. It's going to be easier for me not to simplify. So what will I do now? Divide by root 50. Now I'm going to go to my calculator, and what do I type in if I want to know that angle? What do I type? Second cosine 1 divided by the square root of 50. And it tells me that the angle between those two vectors is what? Anybody have a calculator and typing it in with me? Hey, I know it's Monday, but we have a lot to do. Come on, let's get focused. If you're hungry, go get some food. Otherwise, sit up, PJ. Come on, let's get engaged. I got 81.87 degrees. Anybody match that? Yep. That's the answer to the question. All right, now listen. Listen. Let's go through one more time, and then we're going to try number 2. What is the rule? When it says find the angle between two vectors, what's the rule? Dot product, which you know how to find, equals magnitude times cosine. Right? So here we go. Dot, our two vectors are 3, 2, and 5, 4. So we're going to find the angle between these. So dot product equals mag times cosine. That's my little abbreviation. Magnitude times cosine of angle between. All right, so what's my dot product? Let's start there. What's the dot product of these two vectors? 23. Perfect. Now, how do I find the magnitude of 3, 2? What do I do to find the magnitude of 3, 2? I do the Pythagorean theorem. I might want to draw a little picture. Over 3 up 2. What's the Pythagorean theorem tell me about the hypotenuse? Root 13. And then what do I do? magnitude of the other one. So do the same thing, but this time it's over 5 up 4. So that length would be
6.
not 6.
What do you mean?
Do the Pythagorean Theorem. What's 5 squared?
41.
Square root of 41. Right?
Yeah.
And times cosine, and I do not know that yet. That's my variable. Okay? Now, before you start, let's multiply these two together. The square root of 13 times the square root of 41 is just going to be the square root of 533. It's easier to do the problem if you put those two together before you go to the next step. Everybody okay with that? All right, so what's the next step? What does cosine theta equal?
23 over.
Yep. And then we'll go to our calculator, and what do we type in? What buttons? Second cosine. And I came up with 4.97. Anybody match that? That's a very tiny angle. Anybody match that? All right, look at question C. It looks different, but isn't it the same thing? What's the only difference? This time, instead of just giving you the numbers, I drew the picture. All right, would you do C on your own? Would you find the angle between the two vectors in problem C? All right, so we're finding the angle between the two vectors, 6, 4, and 2, negative 3. So everybody should have step 1 done. What is our first step?
Dot product.
We do the dot product. And oh my goodness gracious, what happened when you did your dot product? You got 0. Okay, that does not change a thing, boys and girls. That just means your dot product is 0. That's allowed. So then what's our next step? Magnitude is 6, 4. All right, find that for me. You know what to do. Draw a picture of it and do the Pythagorean Theorem. That's how we find magnitude. Do it, PJ. Get a pencil out.
I don't have a pencil.
We'll borrow one. You got a friend, I think. Find the magnitude. And really, you don't even need to draw a picture. I mean, it helps us a lot of times. But don't we just square this number and square this number and add them together every time? So what did you get? The square root of 52 times square root of 13 times cosine theta. All right, and then remember, just to help ourselves, we'll go ahead and multiply the 52 and the 13. So we got 676 cosine.
I did something different. I don't know if I did it right, but you know you can like simplify the radicals. So, like I got 2 and 6. And then another 2 and 13, so I got 2 and 13.
Okay, this is actually 2 root 13, and this is root 13, so this is actually 26. Is that what you're saying? Yeah, that's fine. It doesn't matter. Because now what I'm going to do is divide. And when I divide, no matter how I write this, when I divide, don't I just get 0? Isn't 0 divided by anything 0? All right, so now I go to my calculator, and what do I type in? Second cosine 0. And what does it tell me about angle theta? 90 degrees. Wait a minute. The angle between these two vectors is 90 degrees. What does that tell you about these two vectors? If they make a 90-degree angle, they're what? They're perpendicular to each other. Now, do you know how we have this new language in vector land? We don't say length, we say magnitude. Well, we don't say perpendicular. We say orthogonal. So write that word down. Orthogonal means perpendicular. So if you have a vocabulary quiz and it says, what is the vector word for perpendicular? You will say orthogonal. If the question says, what does orthogonal mean? You will say it means they are perpendicular. And why did that happen? Because when you did your dot product, you got a 0. Every time you get a 0 here, this is going to happen. Does that make sense to you? So if you get a 0 for your dot product, you don't really even need to do the rest of this stuff. You know it's going to come out to be 90 degrees. Now, if you go ahead and do it all, it's going to come out to be 90 degrees. But you can skip all that. Because every time that's a 0, you're going to get a 90. Okay? Is your hand up?
Yeah.
What?
Why did they come up with a new word?
Vectors and matrices just have their own language. I don't know. There's probably a reason for it. I just don't know what the reason is. All right, let's do the last one. Here we go. Our two vectors are -2, 4, and -5, -2. And you're going to find the angle between those two vectors. All right, so who remembers how we start? Dot product. All right, what is my dot product? Watch your SIGNs here. A lot of negatives floating around. What is your dot product? 2. Very good, Zach. Very good. 2 is your dot product. 10 and -8. How do we find dot product? X times X, Y times Y. Add them up. Now, what do I need next? Magnitude of the first vector, all right? Tell me what am I going to get for the magnitude of my first vector? Root 20. You can reduce that if you want. I would not. I just leave it root 20. What's the magnitude of this guy? Root 29. Now, let's go ahead and multiply those two together. So we only have one number instead of 2 to deal with. So 2 equals the square root of 580 cosine theta. By the way, is this one going to come out to be 90? No, the only way they come out to be 90 is if that is a 0. This is not. So we're going to divide. And what does theta end up being? Well, I don't know, but let's do it. Second cosine 2 divided by the square root of 580. I got 85.24. Yes, as long as you're getting the same answer, it's absolutely fine. Yes. All right, we have one more section to cover before we start reviewing. So let's look at this next section that says are these vectors, let's look at the first one, are they parallel, orthogonal, or neither? Okay, now, we haven't really talked about parallel, but we have talked about orthogonal. What do we know about vectors that are orthogonal? What will always happen if they're orthogonal? Okay, it's a 90-degree angle. And to get a 90-degree angle, what has to happen in this equation? The dot has to be 0. So let's find the dot product. If the dot product is 0, then what do we know about these two vectors? They're orthogonal. If the dot product isn't 0, then we know they are not orthogonal. So let's take care of orthogonal first. All right, what's your dot product? All right, these are orthogonal. Done. The dot product is 0. Kids, we already talked about it. I need you to be engaged. I need you to be thinking. When the dot product is 0, the angle will be 90 degrees. 90 degrees means perpendicular or orthogonal. So if your question is, are they orthogonal, you'll do the dot product and get 0 or not. Okay, number 2, or B, 2, 1, 6, 3. Is the dot product 0? No. So what do we know about these two vectors? They are not perpendicular. They are not orthogonal. All right, so my choices are now, they're either parallel or they are neither. So I want you to think about this. This vector goes over 2 and up 1. This vector goes over 6 and up 3. Now you don't have to draw it, I'm just drawing it so you can visualize it. Tell me about the slope of this vector. If it goes over 2 and up 1, what's its slope? It's not 2. What's the slope? Slope is y over x. What's the slope? Isn't it 1/2? Over 2 up 1, that would be 1/2. And what's the slope of this line? 3/6. Wait a minute. If two things have the same slope, what's their relationship to each other? They're parallel. These guys are parallel. Now, you do not have to draw the picture. I want you to notice that isn't this vector just 3 times this one? So if you can tell that they are multiples of each other, then that means they have the same ratio, 1 to 2, and they will be parallel.
Is there a different name for parallel?
Nope. All right, let's look at the next one. 2, 1, negative 5, 7. Now, stop. Are these multiples of each other? Kids, take 3 times both of these. Don't you get this? That's what I mean by multiple. Are these multiples of each other? So these are not parallel. I can tell by looking at them, they aren't multiples of each other. They're entirely different ratios, not parallel. How about orthogonal? How do I tell if they're orthogonal? The dot product would be 0. Is my dot product 0? So what's the answer to this one? They're a neither. These are just 2 random vectors that have no relationship to each other. All right, next. Negative 3, 1 and 2, 2. Are they multiples of each other?
No.
Kids, this is not a difficult concept. A multiple of 2, 2 would be 4, 4, 6, 6, negative 8, negative 8. Take this times something. Is there any way you can take this times something and get that? No. These are not parallel. They are not multiples of each other. The slope of this one is negative 1/3 and the slope of that one is 1. They are not parallel to each other. What is their dot product? I don't know, but it isn't 0. So this is another example of a neither. -3, 1, 6, -2. Now these numbers look a little bit related to me. They're not totally separate like these. These look kind of, I got 3s and 6s and 1s and 2s. What's the slope here? Back 3, up 1. What would the slope be? -1/3? What's the slope here? -2, 6. Uh-oh, what about these two vectors, guys? They're what? Parallel. These guys are parallel to each other. Why are they parallel to each other? Because their slopes are the same. If you took this guy and times him by -2, you'd get this. They're multiples. And the last one, tell me about those. They're orthogonal. Why is the last problem orthogonal?
Because it's dots.
The dot product equals 0. Recap. How do we tell if vectors are perpendicular?
The thing is 0.
How do we tell if vectors are perpendicular?
If they have a dot product.
If they have a dot product of 0. Period. Do the dot product. How do we tell if they're parallel? If their slopes are the same, or sometimes you can tell that just by looking that they are multiples of each other. If they are multiples of each other or their slope is the same, they're going to be parallel. If they're not either one of those, then they are neither. Okay? All right. Now, I want to hand out. Okay, that's yours. I want to hand out a practice quiz. This is to make sure that we haven't forgotten everything we learned last week. Okay. All right, so here we go, everybody. I just looked out the whole row.
So good.
No, okay. Sorry about you guys. Sorry about that. Oh, here we go. I got you guys. Okay. All right. So here we go on our practice quiz. Okay. So Lily ended up coming in. We have Lily. Lily, did you bring a pass? I see it. Yes. Thank you. And Jamal is. Okay, but I'm still missing. Okay, here we go. All right, so here we go. This is our practice quiz. Our real quiz is going to look just like it. So here we go. Number 1. You know point A and point B, and your job is to give me the coordinates of the vector that goes from 1, 2 to -3, 4. This is easy. We're going from here to here. Tell me how it moves. If it goes from here to here, what do its x's do? -4. What do its y's do? There's the answer to the question. Kids, you are seniors in high school. If you can't tell me how far it is from 1 to negative 3, then we're in trouble. Now, question number 2 says, are BC and V equal? Why or why not? Now, if they are going to be equal, then don't they have to move the same way? We already know that V is negative 2, 3. It tells me that in the problem. I need to figure out what happens with BC. So here we go again. Now we're going from B to C. How does BC move? Well, from B to C is what? In the x direction. 4. Well, I can already tell they're not going to be equal, but I'll go ahead and finish it. How about y's? How do the y's move? Are those equal to each other? No. How are you going to answer the why or why not? Their coordinates don't match. And instead of the word coordinates, you can use the word components. Both words are used. It makes no difference to me which word you use. Their components don't match. Period. If they matched, then the vectors would be V plus 2W. Now let's get a little vocabulary down here. We've already talked about these words. We're going to reinforce them because you're going to be held accountable for this vocabulary. The number 2, anybody remember what we call that? It has a special name. It's called a scale. Very good. Anybody remember what we call it when we add 2 vectors together? This is going to be an addition problem. When I add them together, anybody know what we call that? It's called the resultant. The resultant is the sum of 2 or more vectors. I thought I'd given you that word, but maybe I didn't. The resultant is the sum of 2 or more vectors. So anytime somebody says, do you find the resultant? What they mean is find the sum. Okay? All right, so I'm going to find the resultant of these. All right, so how do I start this problem? We got our vocabulary taken care of. What do I need to do first? I need to find out what 2W is. So I know V is negative 2, 3. And what would 2W be? 2W would be 0, 8. Now I'm going to add these. You are just straight up adding them. So what do you get when you add the x's? What do you get when you add the y's? Here's the answer to the question. Negative 211. That's V plus 2W. Negative 211. What is question number 4 asking me? Magnitude. So vector V looks like this. Negative 2, 3, left 2, up 3. That's what vector V looks like. So what would its magnitude be? Root 13. We've done magnitude about 15 times today already. How do we find magnitude? Pythagorean Theorem. It's the length. This is the magnitude. Find a unit vector in the same direction as negative 2, 3. We talked about this on Friday. Who remembers how we find a unit vector? Look at your note sheets if you don't remember. How do we find a unit vector? Very simple. Very simple. What do?
You find the magnitude
Okay, which I already did. I got it right here.
You put it over 1, or you put it under 1?
Well, not necessarily under 1. I put it under something. What do I put it under?
Oh, you put it under the components.
Exactly. So the components of the vector are -2, 3. So I just put both of those over root 13. And then I rationalize, so that would be -2 root 13 over 13, and 3 root 13 over 13, and there will be the answer to the question. Kids, you have got to remember stuff from one day to the next, okay? We cannot keep relearning everything. How do we find the coordinates of a unit vector? It is so simple. You take your original vector and divide it by its magnitude. That's it. Every time. Now, we're switching gears here. Number 6 is a separate problem. Find the components for the vector shown. Now, what do we mean by components? What are we looking for? The coordinates, which means we're looking for x comma y. So do you remember we did a whole bunch of these the other day? How do we do this? Where are x and y in the picture? Isn't this x and isn't this y? So don't I make a triangle and say here's x, here's y? And then what? Look back at your notes. We did about a zillion of them.
So you'll do x over 10 equals cosine 42.
Exactly. Cosine 42 equals x over 10. Thank you, Jamal. We're just using SOHCAHTOA, right triangle trigonometry. Right? So x equals 10 cosine 42. Right?
Yeah.
And I go to my calculator and I type that in, and it gives me the x coordinate of the answer. So 10 cosine 42, 7.43. Now, how do I do y? Same thing, only it's sine 42. So I type in 10 sine 42, and it's 6.69. And there are the coordinates of your vector, or your components, whatever vocabulary you're using. All right? Number 7. Find the magnitude and direction of -2, -5. Oh, -2, -5. Magnitude is a no-brainer. We've talked about that a ton of times already today. What's the magnitude of that vector? How long is that? Root 29. Everybody's got the magnitude. Now, this is the actual direction, kids. That angle is going to be the answer to the question. But you can't find that angle first. First, you're going to find this angle, right? Let me call it theta. Now, how am I going to find the measure of that angle? What do I know about that angle? I know its tangent is what? Five halves. The negatives cancel. I'll just say 5 halves. Tangent is opposite over adjacent. Now, how will I find that angle? Second tangent, 5 halves, and it's 68.2. Now the answer though is not 68.2. The answer is 180 plus 68.2. So your direction, wait, your direction is 248.2. All right, we'll do the last one tomorrow, and our quiz will be Wednesday. Okay? Our quiz will be Wednesday. All right, have a good day. Happy Friday. Have a good day.
I can't do